Yeah. Uh, Good morning to everybody, and I'm very happy that National Conference on Engineering and Innovations in Engineering and Management has organized this innovative activity, finding out the young talent who are interested in contributing to the innovation, uh, disruptive innovation, and change in Indian society, particularly the rural India. Uh, as we all know, there are 6,46,000 villages in India, and almost 69% population still in India resides and dependent on the rural market, agriculture, and agri-related activities. We have to understand that the dependability of Indian economy in terms of education, in terms of jobs, in terms of employability, in terms of providing food security to the urban and rural community, in terms of export, about the rural agro business, rural uh, business of weaving and allied activities. Food processing, fruit processing, export only units into the agri sector, agro-based sectors. All these sectors are contributing to the uh, development of the economy, though the overall contribution of the agriculture sector in our economy is 19% of the GDP. But if you take into account the industries based on the agriculture produce and allied produce from the agro-based economy of our India, we have to understand that India is predominantly still agro-based economy. And if you want to make the changes in India, we have to make changes in Bharat. And we are ahead in making progress in India, that is urban India, but not in Bharat, that is rural India. So, how our new generation can contribute innovatively in changing the structure, changing the economy, changing the agriculture sector, which is providing food security to all of us. And agriculture sector, in a way, is a sick sector. And still, our farmers, despite drought, despite loss due to natural calamities, loss due to prices coming down of agriculture produce, still, despite being making losses years together, they are into in this industry. Just imagine any uh, manufacturing sector, industry, or any other industry, if it is sick for years together, will that owner of that company industry will continue doing production, manufacturing? Will he or she remain in the sector? They will not. They will close down their sick units. They will declare that they are bankrupt. But despite being a lot of obstacles, sickness, consistent sickness, drought, natural calamity, the calamity from the government policies and all other dependable factors, they are sustained into agriculture sector. So how we can change the fate and the ground reality to become a change agent of rural community, that is a big challenge. So rural transformation program with the young minds, the brilliant young minds of our new generation, millennials and Generation X, can apply their knowledge, apply their mind, think creatively, identify the small solutions to the problems the rural community is facing. And that too, that should not be, overall for India as such. No, in every state, in every district, in every village, the problems are different. The dimensions are different. Issues are different. Crops are different. Job patterns are different. So how we can come out with a solution to solve the problems, that is what we say, the problem-based learning. And you will learn a lot by providing a small solutions which doesn't require much human capital, doesn't require much capital investment for providing solutions. But the innovative minds are required, disruptive innovations are required, which will provide solution to the problems facing in the rural India and the rural transformation. For example, how we can increase the organic farming method, which was traditionally done by the farmers, that is called as sustainable agriculture, and how agriculture produce can be nationally marketed, globally marketed, and producing local products in a local market, because the transportation cost will be reduced. All these small initiatives having a marriage of export-only unit in agro-based industry, and as well as providing quality agro product to the local market, regional market. For example, I will just cite you one example so that you will understand why we need to do the engineering and management into this sector for rural transformation. The jawar, bajra, and ragi, these are the millets which are known as the best millets in the world, not in India. And for that, lot of coastal areas in India, they produce ragi. Maharashtra, Karnataka, and some part of Andhra, they produce jawar and bajra. If we concentrate on the quality of these food grains, millets, if we identify the ingredient of these millets, and if we start export business of jawar and bajra and ragi, ragi is a food item for whole of Africa. 52 countries, 1.5 billion people. So, can we market our Indian millets into the world market by producing quality jawar and quality bajra and quality ragi? Why not? One example I am citing. We are one of the top producers of milk. Can we do some innovation into that, collaborating with milk producing countries in the world, European countries in the world, collaborate with them, come out with milk processing units, producing requirement of milk products all over the world, as well as many other such areas in which we can enter into and work into. In engineering, what is happening? We are producing 1.5 million engineers, graduates every year. Only 20% are employable. And if you see the competency, new age competencies, skill competencies, for example, like artificial intelligence, machine learning, robotics, Internet of Things, blockchain technology, big data analytics, you will find that only there is a recent survey which says that only 3.5% engineering graduates are acquired these skills, in which there is a huge employment opportunities present and the years to come. How to re-engineer the engineering education? How to provide these kind of futuristic skill requirement, future skills, what we say, to the engineering graduates, and I am against of the opinion that engineers are not employable. They are employable. Only thing, they have to empower themselves with the required skills of present times and future times, and they should become the future ready. At the same time, what they can do, they can enter into the entrepreneurship area, and they can provide jobs to others. Instead of becoming job seekers, they can become a job providers. And lot of schemes are there. Government of India schemes are there. State government schemes are there for promotion of entrepreneurship, startups, and all other missions are there. How can we exploit those for the betterment of the social entrepreneurship mission? Social entrepreneurship, providing solution to the present problem, empowering the rural population, the poor population of our India, and through that you are going to earn, and you are going to generate employment. Is this possible? I think this is possible. If 10-20% of our youth decide to become entrepreneurship as a change makers or change agent and enter into the new kind of government, the entrepreneurs, those who are disrupting the present structure of India. There is a concept of unicorn companies. Unicorn companies. I will request young minds to study that. What is unicorn? The startup, within 7 years of their time establishment, becomes $1 billion company. That company is called as unicorn company. There are more than 500 such companies in the world which have become unicorn companies within 7 years of their establishment, startup, and now they have become a unicorn company. In India, we are having around 15 to 20 such companies of recent times, and I am happy to share with you, young minds, young brains, that during even this pandemic period, we got 5 such unicorn companies in India. Why? Because something innovative, disruptive, innovative ideas, digital technology deployment, and ideation of different kind has cracked in the mind of the young mind, and they have started their startup with little bit of capital they are having at disposal, and the venture capitalist had invested into that. That kind of initiatives are required from the young engineers, young management students, and they can come out with a solution by collaboration, cooperation, co-creation, co-production for Indian market, regional market, national market, and as well as for the global market. We can be providers of food items to the whole world because our economy is agro-based. Why can't we initiate export only units, EOU, for exporting agriculture produce with full quality control, organic? If you produce organic vegetables, organic fruits, organic food grains, then the European and other developed world people are ready to pay 3 times, 4 times cost for the same. Can we initiate such kind of things? There are people who are doing this. I appreciate that spirit, but we also can do that. That is my suggestion to young minds. I am saying we are in a difficult times, no doubt about that. Because of pandemic, reoccurrence of pandemic, with the second wave, and there is a possibility of coming third wave of COVID-19, and many such zoonotic diseases are going to attack us. In that situation, crisis situation, how we can come out with different ideas which will create these challenges into an opportunities and provide a solution for the problems our rural population is facing, as well as the whole developing world, least developed countries, LDC countries, as well as developing countries are facing in the world, of which population is about 70% of the world population. Poverty is there, unemployment is there, economy is in poor shape, stability is not there, democracy is not there, lot of conflict prone zones are there, war prone zones are there. If we don't have peace and democracy in place, there cannot be progress, and we cannot achieve the progress without that. And therefore, I personally feel the management education, management practices, as well as engineering education and engineering practices have to change. And we at Nciem University have come out with a new type of engineering education, which we call as Mahatma Gandhi's Nayi Talim in engineering education, learning by doing. Because the engineering graduates are not able to engineer anything, therefore they are not employable. They don't possess the required skills which industry needs. They don't have guts and spirit to fight the odds and obstacles in their life, and courage to dive deep into the troubled waters and swim successfully for the taking the challenges of life. And that kind of spirit is required. And for that, we have taken up the mission experiment, transforming engineering education mission, with the help of Vikas Patil, who is into the construction industry in Muscat, globally known project management in the construction industry. And we are doing one experiment, that why can't every student of engineering institutions in India can become employable or can become entrepreneur. That is a possibility. At the time of concluding my message to all of you, just I came across with the Westpreneur. Entrepreneur, like there is a Westpreneur. The entrepreneur working into converting waste into wealth. We all know that e-waste is processed and make recycled. Likewise, every element on this earth can be recycled. There are solutions of biological control, converting bio-waste into fertilizer. I have come across with Professor Khan from Bangladesh, who made alternative to the plastic by using jute byproduct. And that plastic is degradable and becomes fertilizer after use. What an innovative idea is this? Can we experiment in this domain, by which we can protect the environment? We can convert our waste into wealth. Any kind of waste. Nothing is waste. Everything is wealth. But the processes, technologies, ideas are required to convert that into wealth. Therefore, if you look at the present problems with a creative angle, new engineering angle, new management angle, then you can provide solution to the waste and converting that waste into wealth. That is also a possibility. And lot of innovators in the world, they are in teens, teenagers, but they are providing solutions to the world problems. Therefore, I believe in this new generation Z, which is post-millennial generation, but they are exposed to knowledge, media, and they have a global connect, and they have a local connect, and they are ready to produce, think innovatively, and provide a solution to the problems we are facing. My friends, we are in a knowledge economy. And knowledge is the driver of economy, not the capital. When knowledge is a driver of economy, when idea is a driver of economy, idea leads to the prosperity, then only what we require is very active brain. And for that brain, we need knowledge, we need ability to apply that knowledge, we need ability to convert that knowledge into a technology. Technology doesn't need huge capital, just ideation is important and application is important, and create that technology. There is a makers movement going on in India and abroad. Makers movement is that you have a lot of raw material, low cost raw material, including West and non-West, and you are working on that, and you are creating prototypes, product, and getting patented. Some are commercial patented, some are community patented. But that can happen. And that kind of approach is required for the betterment of humanity, not only in India, but the whole world. And that spirit is required. If you have spirit, you can change the economy, you can change your fate, you can change the fate of people around you. You can become a change maker instead of job seeker. And you are the leader of the future. And that leadership skills, problem solving skills, going beyond our own career thinking is required. And I'm sure that when you are thinking for others, thinking for society, thinking for nation, and thinking for humanity, thinking for nature, you can be a change maker, and that change will be internal and external as well. And therefore, at the end, I will say, that think globally and act locally. That is the concept everybody knows. But I have expanded that. Think globally, act globally. That is also an opportunity of thinking. Think locally, act locally. That is also an opportunity for playing. That is the play field. Think locally, act globally. How local talent, how local wisdom, how local produce, how local technology can be given as a technical know-how to the world. How we can sell Indian produce, Indian product, Indian food, hospitality, whatsoever area, you can think locally and act globally. In a global world, in a digitally driven world, in a digitally driven society, digital economy, I will suggest all of you to think differently and act locally as well as globally. That will change your fortune. And for changing the fortune, you need study, you need observation, you need differentiating thinking. Thank you very much. All the best for this event. I appreciate the very concept of this event, and I congratulate convener Partha for organizing this. Partha, you have well done, and you are always thinking differently and acting very active person who is spirited to make changes in our society, change the particularly the engineers and engineering a new kind of India which has been imagined by the leaders of our country. Thank you very much. Jai Hind, Jai Maharashtra. Yeah. Thank you. Yeah, 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 yeah. Uh, Dear friends, on behalf of the organizers of National Conference, Innovating Engineering and Management on rural transformation and rural development, I declare that this 2 days conference is open, and I expect that the 30 young minds of India will definitely come out with different qualitative initiatives, and few of them will transform their ideas into a reality, and that will be a role model for the other young minds and brains of our country. Thank you very much. Welcome.
Yeah, good morning, everyone. And it's yeah, myself Abdul Shakur. I am official mentor of Adult Innovation Mission, Niti Aayog, and also ambassador of Institution Innovation Council, Ministry of Education. And apart from these academic thing, I am actually belongs to the other side of the entrepreneurship, that is on the real entrepreneurship. I'm working as a CEO of Abir Food Industries, and also I have my own consulting platform in the name of Integrated Consulting Services, which caters to the need of the young entrepreneurs or enthusiasts who want to start their entrepreneurship journey. So these are the basic things that I'm personally engaged in, and I'm looking forward to this session for everyone's benefit. Let's see how we can evolve as a system. And Dr. Partha has taken an initiative for making this post-COVID scenarios pushed us to this virtual uh, community built up regarding the startup enthusiasts and entrepreneurs and innovations and all those things in every field. So, and we are trying to connect to the rural remotest part of India through the platform. So that's the whole idea behind the integration that we have with Dr. Partha. So I hope it will really begin the journey of a new way of working and towards the development and making Atmanirbhar Bharat the self-reliable and self-sustainable. So all the best to all the participants, and a special thanks to our VC sir, and for you know uh, giving us an opportunity to start the initiatives of this kind. So thank you very much.
Great, great. Okay, okay, okay. Yeah. Yeah, nice to listen to you, Shakur, and I hope that with your initiatives and contribution and experience, you will nurture the culture of startup in India. And basically, the young entrepreneurs who want to enter into this domain, that culture promoting this kind of courage is not there in India. Discouraging environment is there in institutions, at home, in society, and at the same time, the failure issue is also high. But see, through failures only we learn and we improve and we grow. So anyway, in the job market also there are failures. You lose job, you get job, you are thrown away. A lot of problems are also there in the job market also. So same is the case with the entrepreneurship sector. So the youth of our generation should understand this and be ready for failures, learn from the failures and move ahead with the courage and passion. That passion is very important. Struggle is very important. The struggle is a great educator. Okay. Okay.
Yes, sir. Hello. Am I audible? Sir. Yes, sir. Yes, yes, sir. Hello, everyone. So I'm going to present it now. Yes, sir. I'm already. My video is on. Actually, I'm doing it from two devices, so I have to. Okay, sir. I'm presenting now. Is my screen visible? So, hello, everyone. My topic is on-site forest fire detection and monitoring. Basically, forests are usually the best source of flora and fauna. Natural disasters like forest fire usually destroy the human and animal lives, eh, the raw minerals, the natural vegetation, the ecosystem of the whole forest. The major issue in the forest are they are huge, unguarded, have no proper communication system. During the past few years, these forest fires have become a huge crisis which are difficult to manage. Existing system based on IoT usually detect the forest fire after it has been spread over a huge area. Therefore, a system is required for the detection of the forest fire in the early stages of the fire. It can be achieved using the Lora module. Lora, what is Lora? So, Lora helps to connect two low-end devices on large geographical area, and it is based on LoRaWAN. The proposed system is also validated in cloud database using Wi-Fi module. And data is collected using three sensors which are used for monitoring the environment. Whenever a fire is detected, LoRa transmitter sends the information to the receiver, which in turn switch on the buzzer. Further, an SMS is sent using the GSM module at the receiver end. Investigations reveal that the LoRa approach beats the general satellite methods as it detects the fire in its initial stage, thus reducing the loss of flora and fauna. Now the introduction. Now, forest fires are a great barrier to ecologically healthy grown forest. Forest fire is one of the major causes of global warming. During the year from November 2018 to February 2019, forest fires have been raised from 4,000 to 14,000. And recently, over 1.25 billion animals have also died in the Australian bushfire season. The detection systems which are used do not provide quicker response, which is very important in forest fire. So the basic objective of this work is to design and implement an IoT-based system which is self-sustaining and would predict and detect the forest fire and send the emergency message to the respective person. So basically these are the purpose of the project. The most important goal is the fire surveillance and the quick reliable detection of the fire. It is so because it is much easier to suppress fire while it is in its early stage. And the area of the forest is very large. It is far away from the urban area network coverage. It is a challenge for the communication between sensor and receivers to exchange the data. So LoRa is suitable for wireless. It is a suitable wireless communication technology to achieve long range communication. The existing system which are present, there are basically three types of system. So there are fire alarm system with the buzzer, fire alert system with no continuous monitoring system, and highly expensive satellite monitoring system. The limitations are satellites usually detect the forest fire after it has been spread over a huge area. During this time, lot of damage is already done to the natural ecosystem. And even the existing system based on GSM require better network connection to exchange data between the sensor and receivers. GSM sensors include a SIM card of any network, and the network should be available in the forest. That are the major drawbacks. Now, what is my proposed system? A proposed system is the microcontroller, which is used to control the system activities, and some sensors are also used to detect the fire in the forest. The three sensors which are used basically are the humidity sensor. It measures the temperature and the humidity. During the fire, there will be a steady increase in the temperature. And there is a fire sensor, and it is used to detect the response of the fire. And there is a gas sensor, which checks the changes in the composition of the gases in the atmosphere. The smoke level also increases in the forest. There is an also inbuilt GPS which is used to know the exact location of the fire in the forest. So here is the transmitter side of the detection system. There are three sensors: the Arduino Uno board and the LoRa transmitter, GPS, and there is a Wi-Fi module which sends the data to the database, which can be viewed by the respective person. Now the next connect to the Arduino. And there is one GSM module used to transmit the alarms to our control center. And there is a buzzer which is used to give an alert signal. So here is it, the receiver side diagram. Here the GSM module is used to send data to far and far control center. Now what is the benefit of this system? Both the local and the global fire alert is provided. Local alert using the LoRa module, and the global fire alert is used to the GSM module. The most important goal in the system is a quick and a reliable detection of fire. It is so much easier to suppress fire while in its early stage. It is very low. It is a very low cost implementation comparison to the satellite methods. The area of forest is large. It is far away from the urban area. So it is pretty useful in this situation. LoRa is very pretty useful in this situation. Here is the flowchart of the system. Now the implementation. Various modules involved in project are: the sensor collects the data, sends it to the Arduino. If fire is not detected, the Arduino sends the data to the cloud database through the Wi-Fi module, the ESP8266. If the fire is detected, Arduino sends the data to the LoRa receiver to the LoRa transmitter. After LoRa receiver gets the information, the buzzer sends an alert signal through the receiver. Receiver Arduino sends the alert message to the nearby forest base station using the GSM module. The three sensor use the the fire sensor. It is a small plate output interface, and a single chip will be directly connected to the PC input output port. There should be minimum testing distance between the fire sensor and the fire should be 80 centimeter, and it can find the flames of wavelength 760 nanometer to 1100 nanometer. 60 degree is the angle of the detection, and they are extraordinarily insensitive. Yeah, sensitive. Gas sensor MQ contains a chemiresistor that reacts with the certain gases that is used to check the change in the composition of air. DHT22 uses thermistor and capacitive humidity sensor to check the change in temperature and send a digital signal on the data pin. Now about the LoRa module. In LoRa module is connected to the Arduino. On the both side, the transmitter and the receiver, they both have 16 pins. From the 16 pins, 4 ground pins and 16 pins are used by GPIO pins. The operating voltage is 3.3 volt. 3.3 pin volt pin of LoRa is connected to the 3.3 volt pin of the Arduino, and the rest all connection. For in the receiving side, there are all the connections are almost similar, but the only difference is the external 3.3 voltage is given to LoRa rather than the Arduino one, because the Arduino Nano onboard regulator cannot provide enough current for the LoRa module to operate. All the remaining connections are similar to the transmitter side LoRa. And now the Wi-Fi module. The Wi-Fi module is configured using Arduino IDE on the desktop, and required packages are installed. Once the packages are installed, the script, which is responsible for establishing connection between the Arduino and ESP8266, are installed. On the receiver aspect, the buzzer devices provides us associate degree sounding, like a sort of signal. GSM module is also connected to the receiver side Arduino, and it is done using various pins are attached. The RX pin of Arduino to TX pin of GSM, the TX pin of Arduino to RX pin of GSM, and the ground pin is connected to one another. Now, so the conclusion. An IoT-based forest fire detection is the Arduino. So when the temperature is increased, it will give an alert signal and also give the message to authorities. By using these techniques, we can protect the forest and wild animals. Our system will play a crucial role in curbing the forest fire, which would prevent loss of use, resources, and financial losses. Once again, I would like to thank everyone. Thank you, sir. Any questions, sir? Yes, sir. Yes, sir. Yes, sir. Okay, sir. Sir, actually, my project consists of 3 modules. All, uh, sir, it's already unmuted, sir. Aman Bokadia. I have logged in through 2 devices. You can see one more Aman Bokadia. Sir, actually, in my project, there are 3 modules. The GSM module is also there, the Wi-Fi module is also there, the LoRa module is also there. The Wi-Fi module, which you are saying that in the forest area it won't work, it is just for monitoring, sir. The main part, or the main, if the fire is detected, the LoRa module is used. LoRa module is basically a transmitter receiver type module, sir. It has a very low bandwidth, sir, so only sensor data can be exchanged. So if a fire will be detected, it will be sent using the LoRa module to the transmitter to the receiver. The Wi-Fi module is only there for the for the monitoring purpose. It is not, whenever the fire is detected, it will be send a alert message only through LoRa module. Sir, I am in the 4th year, sir. Yes, sir. Uh, yes, I'm trying to make a prototype first. I already tried. Results have been successful yet, but I will work on the commercial part and everything, like the making part. Yes, sir. Thank you, sir. Okay, sir. Thank thank you, sir.
Good morning, sir. Yes, sir, I am. Who is infected will cough, sneeze, or even speak next to you, and you breathe in that air, you can get infected by tuberculosis, which is why we should address this disease as one of the ones for which we should find an alternative solution. Now, some of the symptoms, as you can see, are here below, which basically, if you consider fatigue, weakness, weight loss, people would not realize that they could actually be suffering from tuberculosis, and these could be considered as different normal things that we feel we are going through. But in a country as big as the population of ours, I think it is important to address this disease and diagnose it in the early stages, because as per statistics, if we do not have the right treatment, 45% of HIV negative and all HIV positive people will die if they have tuberculosis. Now, what is our paper and project about? It is to use various machine learning models, and the ones which give the best performance, we will use them to make an ensemble model and make it more accurate by adding other machine learning model methods to it, such as bagging, boosting, voting, and so on. And the reason why we want to do it is if we as students can make a model which we can run on our laptop, then smaller healthcare centers which do not have the resources to invest in expensive infrastructure can also run and use similar models once it has been implemented. Now, the field in which we want to use it is healthcare data analytics, because this predictive model can be used for rapidly detecting tuberculosis based on the data set, and thus it can aid doctors and help in beginning early treatment and reducing the number of deaths because of people who could not be diagnosed on time, or they could not get the treatment while they should have. This will help in handling cases faster and reduce the dependency on doctors' availability or even professional equipment. And then it will reduce the workload of doctors, because if most cases can be classified using the model, if there are only a few cases which need expert diagnosis, only those will be sent to the doctors. Now, there are two types of data sets we have seen during our survey. So, one of them is chest x-rays, that is radiographic images, and second is Excel files, which have the symptoms basically listed out about the patients and what they are going through. And the outcome would be to classify whether the person is infected or not. So this is how it would be. Once we have collected the data and pre-processed it, we will be training different models using algorithms, and the best three would be used to make an ensemble model, and its results will be consolidated using voting in the end. So, to give an overview of our paper, to do the same, we have gone through a lot of different existing research papers where we have seen the different methods used by different researchers in this domain. And we have also found the dataset. Most common ones are Montgomery and Shenzhen datasets, which are radiographic X-rays that are used for this research purpose. And our suggestion is to make an ensemble model for the prediction of the disease. And we have spoken about the different machine learning models that we have come across in our paper. And we have concluded that most successful ones are the ones based on transfer learning or neural networks. We have also seen some of them working well with regression or decision tree classifier, but most of them have been using neural networks, and our further work is based on the use of neural networks to build such an ensemble model. That's all from my end. Thank you so much. Yes, sir. So, sir, first we are working on training similar models. We have identified that neural networks are most effective, and we are already working on building and testing the models to see their accuracy. So, if this works as expected, then we can approach basically with our guide a person either to make an app which can be used by healthcare centers. They just have to use the model as it is, or anyone who would be interested in helping in the implementation for a rollout. Yes, sir. Thank you, sir. Thank you so much.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Sir, Arvind is going to go.
Good morning, sir. Sir, I'm Arvind Meher, and my friend Karan Gopal Krishna is going to present our top presentation, Dynamic Text Detection and Recognition, and it is guided by our teacher, Ms. S. Kritika Devi. Sir, as we know, text detection and recognition is a system widely used in the many fields like medical, military, forensic, and many more. It's being researched and implemented in real-time devices and help for human beings to enhance. So we decide to So we are going to use two different OCR model, East OCR and Tesseract OCR, because Tesseract OCR is considered to be one of the best OCR, which is the capability of giving 95% accuracy. But drawback of Tesseract is that it can be only used for text data. So we are using East OCR to take our dynamic input and get the frames with the text and give it to Tesseract OCR for a better output. In this project, we have basically focused on our base project, as we were going to detect any kind of language that appear on screen in a dynamic view, and each OCR is specially designed to tackle the natural scene which we which are like some reflection or some bad lighting in the text, so it will able to overcome those effects and give us a proper detection of text and extract that, and after that we will pass it to tesseract OCR to generate our desired output. And sir, my friend is Karan is going to expand about East OCR.
Hello, I'm Karan. So I'm going to explain the concept about East OCR. Now, as on the screen it presents that its East full form is efficient and accurate scene text. So it's a model which is used to detect text at any scenes and images or in a practical field. So the East algorithm uses a single neural network to predict a word or a line level text. It can detect in arbitrary orientation with the quadrilateral shapes. That is, in 2017, this algorithm outperformed the state-of-the-art methods. The algorithm consists of a fully convolutional neural network with a non-max suppression merging state. The fully convolutional network is used to localize the text in the image, and this NMS stage is basically used to merge many imprecise detected text boxes into a single bounding box for every text region. As we know, we are working on a dynamic area. So what we mean by dynamic in the sense is that we would like to capture the text in video frame. So every time there would be in each frame the position of text would change. So that's why this NMS stage is applied. The syntax detection has attracted many attention in the computer vision field because of its numerous applications, such as instant translation, image retrieval, scene, parsing, geolocation, and blind navigation. The main objective is to precisely localize each individual character in the natural images. To this end, we train deep neural network to predict character region and affinity between the characters. Since there is no public character level datasets, the model is weakly trained in a supervised manner. So basically, in our project, we will use the pre-trained East model to aid that idea. So the East pipeline, the concept of it, is capable of predicting words and line of text at any arbitrary orientation on 720p images, and furthermore can run at 13 FPS rate. So according to the authors, that is what they have proposed. So since the deep learning model is end-to-end, it is possible to sidestep competition that other text detectors typically apply, and including candidate aggregation, the word partition. To build and train such deep learning model, the East method utilizes the novel careful design or loss function. The main or novel idea proposed character level text detector from the Zhang editor as a character level detector using text block candidate distilled by Mercer. Why? Because the fact Mercer could identify individual character limits into the detection robustness under certain situations, such as scenes with low contrast, curvature, light refraction, or a rough surface. Arvind, next slide. So in this image, you can see actually the East works in 3 layers. That is the feature extractor stem, which we can call as PVNet, and it is the output is being transferred to the feature merging branch where the computational occurs. Basically, the feature extractor stem is basically a convolutional neural network. At each stage, we try to deconvolute each part of the image where the text is located. So it's like convolution plus deconvolution occurring side by side. Why? Because it uses a pipelining technique which is mentioned in the feature merging branch. I mean, I can like to forward upon.
Yes, sir. Tesseract OCR is an open source text recognition engine built under Apache license, and I already said that it has the output rate of accuracy rate of 95%, so it is considered to be one of the best OCR. Tesseract uses many of the third-party pages to interact with the program. Tesseract is compatible with many programming language and framework, also through wrapper class. It can be used with the existing layout analysis to recognize text within large document, or it can be used in conjunction with an external text detector to recognize text from an image of a single text line. Tesseract 4.0 includes a neural network subsystem which is built under OCR Opus Python-based library, which uses Nciem implementation and was redesigned for Tesseract in C++. To To recognize an image in a single character, it uses a convolutional neural network in the sequence of RNN and LSTM. Tesseract works in a two-step Tesseract work in a two-step recognition is the final output to gener- to generate the input in a much better way, and it uses LS, LSTM and RNN to give us the final output. Opencv, and we are going to use Opencv as our base of the project, where we'll implement all of the image processing and video processing techniques. Opencv is a library programming function mainly used for image processing. It is available in a Berkeley software distribution. It started as a research project by Intel. Opencv contains various tools to solve computer vision problems. It contains low-level image processing function and high-level algorithm for face detection, feature matching, tracking, and various other things. Some of the main image processing are like image filtering, image transformation, object tracking, and many more. And now our proposed model. In the model, we are taking image, video, and live camera feed input through OpenCV. Then we will do some image processing and video processing technique to our input data and pass that to each OCR. Then each OCR will detect the text in the input and extract the text with a bounding box and pass it to Tesseract OCR. Then Tesseract will recognize text and display or print the recognized text. For analysis metrics, the East and Tesseract both are pre-trained model. We are not going to train any new model in this. We will just use OpenCV to interact with both East and Tesseract OCR. And Tesseract East OCR is trained on ICDA R2015 dataset and COCO dataset, which are with the largest dataset present today for text detection, and it is trained over a ADAM optimizer and with the AMD chipset. In our testing, we have seen that for static data test, we are getting an accuracy of 93%, and for dynamic data set, we are getting an accuracy of 84%. We have taken some few 25 examples to provide us this graph, and this is the output result. And for calculation, we are using difflip sequence manager, which is a Python-based library and uses many functionality to get the check the compare two strings and give us the output of how much similar they both are. And this is some of the result page we have printed out, and we have seen that this is both are dynamic. We are doing this in dynamic time, and these are the frames of the object we have detected. And now Karan will conclude.
Yeah, so in the conclusion, I would like to conclude that with the help of tesseract algorithm to detect the textual information, the East model in static images producing an accuracy of 93.36% and our dynamic images, that is basically a video, of 84.83% at 13 to 16 frames per second on a median spec GPU. Believing such system will improvise according to correct match of N algorithms to produce an efficient OCR to detect the text hassle-free and optimally, which can be used extensively to robotics, forensics devices, augmented reality, only to aid and benefit the marvelous engineered devices to the simple deep learning model. This OCR is a technology that helps digitalize physical documents. It turns images, handwritten contents, and printed documents into a fully searchable digital files. OCR is a great example of how AI solutions are driving database modernization, as these tools are becoming increasingly affordable and accessible. In conclusion, OCR is a very remarkable technology that holds a lot of potential. In this day and age, such tools are already quite advanced. However, optical character recognition is going to look even better in the future. AI is on the way to becoming one of the most influential trends in coming year and revolutionizing information as we know. Thank you.
Thank you, sir.
Yes, sir.
Thank you, sir.
Sir, This kind of idea can be implemented in car technologies, if you want to say in particular, where like, or if I tell in a scenario where we want a parking system and we want to see a text behind anything, or the sign where some text is written there in rough surface which we can't recognize. But with this technology, in an inbuilt car, we can see what is written there. So the text is directly displays on the screen dynamically itself. So in this kind of situation, we can use, or it can be used in physics areas also. Hello, sir. Sir, in further project, we will try to use it as an API. Basically, it can become an application programming interface to any other application, because we are extracting text and outputting on its screen itself. So it can be used in another projects, like I told, in robotics also. So it's a major advantage on that.
So with the varying of training data set, we can use in means in multiple industries or in multiple work. We have to change the training data set to recognize the desired output units, for example, number plate recognition or road sign recognition. Then it can detect means as per the our priority.
Sure, sir. Thank you.
Thank you, sir.
I think Ashutosh is not available. What about Atul Chaurasia? Yes, sir. Atul Chaurasia, sir, and
Yes,
I'm his teammate.
good morning, sir. Good morning, sir. Sir, I will be presenting this screen now. Yes.
So, very good morning to all of you. Our topic, road traffic optimization using image processing and cluster algorithm. I, Aman Gautam, and Atul Chaurasia are doing this project under the guidance of Mr. R. Rajkumar, sir. Atul, can you move forward? So the traffic monitoring and the traffic control has always been challenging task. Installing transportation system based on wide range of technologies have certain practical challenges in their application and implementation. Video surveillance have proven advantages over traditional system based on inductive loop sensors and detectors for traffic monitoring. Accurate traffic density estimation, which is basis to tracking traffic congestion, requires detection of vehicle, assessing their speed and tracking vehicle passing through surveillance zone. Image processing techniques require processing of large number of images frames for real-time application in the traffic management. More efficient and less costly image processing techniques for accurate vehicle detection and density determination are required for developing more effective traffic management system. There is a need for developing algorithms with robust performance under heavy traffic loads and varied environment condition.
Developments in artificial intelligence offers us new visits in image processing for regulating and maintaining of traffic by mechanism and create of neural network for unhidden interest traffic flow. So, sir, the basic introduction of our system is that the standard traffic control system used are very antiquated compared to the fast pace of life that we live today. Manual controlling and automatic controllings are the two most commonly used systems. Manual controlling involves the presence of a traffic police, like sir, on a road, a specific person is present, like traffic police, who will be guiding the traffic. On the other hand, automatic control system use constant timer technology where the signal alters a fixed interval of the time. Like sir, the automatic system which are working now are fixed, like in 24 into 7 they will work automatically. But sir, in our proposed model, we will find the traffic like uh, uh, in our system, sir, we will find the traffic that it will be the control of the system. Like whenever the traffic is less in some part, that will be turned, the signal will be turned red, and if the traffic will be high, then the signal will be turned green dynamically. Atul, can you move forward? Atul, can you move to the next page, Atul?
Yeah, I've changed the slide.
Yeah, just complete the introduction part. Next part, I am asking. Like move to the introduction after the introduction. So the basically the challenges that were faced are like in large metropolitan cities, the Canon clustering alone might not be enough because the large number of gateway manual manipulations might not be enough, and separate system for division based on AI is needed. RFID system can't work properly at a long distance in the cities, and it requires specific details of each vehicle, which may make things complicated in view of management. Older image processing techniques also fail sometime during bad weather conditions and at night. They feature extraction techniques are based on learner scale space technology. Segmentation, background subtraction results may not be perfect because of the changing illumination and the light intensity throughout the days. So our basic objective is to implement more cost-effective monitoring of the traffic, and to have an optimized traffic flow route, and to have better jamming reduction work by departments, and to save fuel and prevent greenhouse effects. Now in our project, basically we have divided it in 5 parts. Like first, we will take an input. The input will be taken. After that, the input image will be pre-processed. Then it will be divided into different segments, and then feature extraction will be done on that segmented image, and then we will, on the basis of the feature extraction, we will classify the image in different types, like it is heavy traffic or low traffic or medium traffic. uh, Atul, move to the next page. One more. So that in image, the process by which we are taking input image is like, in reality we will place a camera on the road, and that will be automatically capture the image on a regular interval of time, and we use in read am read command to take that in our system. Then after, when we have that image with us, we will pre-process it. In the pre-processing step, we will basically reduce the background, unwanted background things in the background, and enhance the image. And then this will be done in 2 parts. Move to the next page, Atul. So we will resize the input image, and then we will convert the RGB image into grayscale. That is because, sir, we do not need to distinguish between two colors of the object, because every object has same value, and when we will convert it into the grayscale, it will be simple for the algorithm to distinguish. After that step, we will do the segmentation part. In the segmentation part, we will define, on the basis of the pixels, we will divide the image in different segments. No two segments will have the no two consecutive segments will segments will be homogeneous. Like a when if two segments will be homogeneous, then it will be concluded into one segment only. So that will help uh, uh, in feature extraction. The segmentation is the most crucial part of our project to be succeeded. It can be done with two things, like we are doing the segmentation on the basis of color and on the basis of the morphological operations. Now on to the Atul. He will explain the feature extraction part.
Yes, sir. So in the feature extraction part, it is basically in the feature extraction part, we basically start from an initial set of the measured data and build the derived values intended to be informative and non-redundant. Because, like we earlier said, the cameras will be taking a lot of photos, and the collected data might be very large and also might have a lot of redundancy, which might not be required in order to process the image. So we will extract the important features from such kind of images and remove the redundancy. Feature extraction is related to the dimensionality reduction when the input data to an algorithm is too large and is suspected to be redundant, like in the terms of both measurements of the vehicles, feet, meters, or everything. Then it is transformed into a reduced set of features, also named as the feature vector. It's done basically in three types: shape features, color features, and texture features. So in the shape features, the extraction is dependent on the different kinds of shapes available in the image, like circular or triangular, anything. The color features are basically we take the color and form the histograms. And finally, in our own project, we will be using the case feature. The case feature is basically uses the non-linear diffusion techniques, which is completely different from the other feature extraction techniques like the surf or star, ORB, or vantage point tree, because such kind of feature techniques usually use the Gaussian scale space. So the Gaussian scale space is actually a fixed scale space. This means that if we have to extract the particular features from a space, from an image, or if we have to identify an object, then that object's size in a particular image should be in a particular range. If it is too large or if it's too small, such kind of algorithms which are based upon the Gaussian scale space may fail to identify those images or extract the features. But the case feature is not like that. It is since it is non-linear and it is based upon the multi-scale features, so it can easily detect the multi-scale corner features from the scale space, and therefore it saves us a lot of time and is more efficient. More efficient in the sense as in the older image processing techniques, we had to use the different algorithms for day and different one for night. But here, if there is proper lighting in the night, like we see in the large metropolitan cities, there is enough street lights. So the case feature can still work. The same case feature which works in the day can still work in the night. Furthermore, it saves us a lot of time by reducing a lot of steps like image subtraction or frame differencing or binarization of the images to reach the final image that can be processed. So once we start using the case features, it basically saves time. It is also cost efficient, saves the processing power, and gets better results. Here we can see the effects of the case features. On the left side, there is the case feature. It was actually an original image of the tiger, and it is able to detect detect and extract and identify both the images and connect them. On the right side, we see ORB, and it is not able to extract the features. We are only seeing a few lines. So that's where the case is different. Then finally comes the classification part. Once we extract the features, we will have we will extract the features from a particular data set, and then we will take a real-time image and compare it with that data set and find at which category does the traffic belong, that is the low traffic or medium or high. So we were working on the project, and we got some of the outputs. Like here we have the left images have more density, the right one has less density. So this is the pre-processing part, the resized images, which is converted to grayscale. Then this was the case feature detection. This is actually for the high density images, and this one is for the low density image. And there were less vehicles on the road. And finally, it gives us it tells us whether the traffic is high, low, or medium. So we are still working on this project, and we are trying to refine this project and get better efficiency and compare it with the other models. So that was all from our side. Thank you very much for listening to us. So. Sir?
Yes, sir.
Well, practically, if we have to implement this, since we are using very simple algorithms, so all we have to do is to make sure that while we are trying to implement it, we need to make sure that the cameras are inclined in a particular way. The cameras, the simple cameras can work too, so it is very cheap. But the thing is that we have to incline the cameras in such a way that the real-time images that are captured by such cameras usually contain the major portions of the road only, and not the background skylines or buildings, billboards, hoardings, etc. That will increase up the task of the feature extraction technique. So we just have to make sure of those things. And once we make sure of those things, any centralized computer by the traffic department can help us to identify whether there is low traffic, high or medium traffic. And then the traffic lights are already under the control of the traffic department, so they can simply turn the lights red or green depending on high or low traffic.
So the Google Maps use phone or the speed of the vehicles with the help of the phone GPS or but sometimes that can give the faulty effect that sometimes coincidentally if some people are stopping on road or side of the road for some buying products, then the road will be free, but still it will show that there is a traffic on that road.
And furthermore, sir, since the Google Maps and everything is based upon the satellite communication, and everybody in that case, everybody must have the Google devices only or Google images only. So furthermore, during the satellite communication, the communication also takes a lot of time. But in the cases of there will be lag of 2 or 3 seconds, 4 seconds, and when we're talking about several images being captured every second, so this may slow up the whole process. But in the case of this image processing, it will be really fast. It will be in the milliseconds.
Yes, sir.
Well, yes. Thank you, sir. Thank you very much.
Yes, sir. Yes, sir. Yes, sir. This is Bhanupriya. Ah, yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Since I'm in. Yes, sir. Yes, sir. Sorry, sir. Sorry for the sound since I'm in native. I'm traveling. That's it. Anyways.
Yes, sir, we are ready.
Yes, sir. Yes. Okay, sir. Thank you, sir. Okay, sir. Thank you, sir.
So basically, our guide is Dr. Suresh. So me and my partner, we are Devang Singh and Madhav Kabra. Myself, Madhav, and my partner is Devang Singh.
Uh, uh, yes. So
So this will be used. This can be used by major streaming platforms like Netflix and OTT platforms, Amazon Prime, and all for improving their recommendation systems. Like recommendation.
uh,
Yes, sir.
good morning. I am Devang Singh. Uh, with my colleague Madhav Kabra, we are going to present our project based on the topic custom-made movie recommendation system using Python under the guidance of Dr. A. Suresh. Madhav, next slide. Next slide. Next slide, please, Madhav. Uh, so here is our abstract. A suggestion framework provide important role in informing a user about various information which is meaningful to him but previously unknown. Moving recommendation frameworks target helping film fans by recommending what film to watch without experiencing the long interaction of browsing, which is tedious and human effort by proposing films individuals. These framework doesn't suggest things which are beyond the normal suggestion, accordingly restricting the decision to explore more. In order to deal with such issues, we have made a hybrid recommender system, which to manage such issue, we made a model dependent on content-based and collaborative filtering technique, which is known as hybrid recommender system, which address drawbacks of most of the drawbacks of present system. Utilizing the technique which is custom made to give persistently unequivocal result to various frameworks. So the test show that the proposed model has powerful prevalence over competition and accomplish the cutting edge result. Madhav, next slide. So here is a problem objective to obtain suggestion from our users will predict their rating for movies which they haven't watched yet. Movies are then indexed and suggested to users based on these predicted ratings. To do this, we'll use previous record of movies and user rating to predict their future ratings. At this point, it is worth mentioning that in the real world, we'll likely encounter new users or movies without a history. Such situations are called cold start problems. Madhav, next slide. So here is our architecture of our proposed system. So we collect the movie data set from the from IMDb. So basically, we are using four modules: simple recommender, content based recommender, collaborative filtering, and hybrid recommender. So simple recommender offer generalized suggestion to users based on movie popularity. Next, we move on to content based recommender. So
So content-based recommender filtering approach using a series of discrete item characteristics of an item to recommend additional items with similar properties. It is further divided into two modules, which is movie description-based recommender and metadata-based recommender. Next, we move on to collaborative filtering. So collaborative filtering technique uh, is a method of making automatic prediction about the interest of a user by collecting preferences or taste information from many users. So we use hybrid recommender, which is the combination of all of the above mentioned techniques to suggest to make best possible recommender, and finally the user get the movie suggestion. Now, next, my colleague Madhav Kabra will continue from here.
Yeah.
Over to
Yeah,
Madhav.
so so there are basically 6 modules in our recommendation, starting from simple recommender, then content based, then movie description, then metadata, then collaborative and hybrid. In simple recommender, basically this technique offers generalized recommendations to each client based on popularity of the movies and votes of the movie. So the more famous the movies are, then it will get recommended. It doesn't. It is just based on popularity and votes. No other criteria is used. So utilizing the cutoff as 95th percentile. So any movie which is achieving 95th percentile of votes, positive votes, it will get recommended. This model is working such that it gives a similar proposal to everybody, paying little mind to the client's very own taste. Moving on, the second module, which is content-based recommender. So in this recommender, the basically it has 2 submodules, and it works based on the content of the movie. Like the person who is watching this movie will get recommendations based on the content, similar content of the movie. So the paper presents recommendation system for movies using different approaches in Python, and all the recommender systems implemented have their own advantages and disadvantages. And so there are 2 submodules. First is movie description based recommender. It is working on cosine similarity. With the help of cosine similarity, it is basically used to predict like how much similar 2 movies are, and if the 2 movies are very much similar, based on this cosine similarity, it will get recommended to another user. Utilizing the TF-IDF factorization, registering the scalar product clearly provides the similarity of movies based on score. So in this way, utilizing scalarians linear kernel as opposed to cos likeliness, since it's a lot snappier. So the second submodule, the first submodule was based on cosine similarity, and second submodule is just based on like a user like me will have how much possible. It is just equipped for recommending movies similar to a particular movie. That is, it isn't fit for taking into consideration user preferences and providing recommendations. So it doesn't give any basically any mind to what a user particular taste is. It is just recommending movies based on the content, the crew of the movie, the cast of the movie, the actor which are similar in first movie and the actor which are similar in the next movie. So if the actors are similar and the crew is similar and the actor is similar, it will get recommended. The movie will get recommended. No other criteria is taken into consideration in this basically. So the fifth module, which you are taking into consideration, is collaborative filtering. And this technique relies upon the possibility that clients like me can be utilized to anticipate the amount which a specific item would be likely by me, those users which have not used that, such that me and other person which are similar, having similar taste, and I am liking that movie, and that user has not watched that movie, but since his and my likeliness is the same, then he will get recommended by that movie. So utilizing the surprise library that utilizes very amazing calculations like singular value decomposition to limit error, which is root square mean error, and give uncommon suggestions like the movies which have not received much votes or which is not much popular, but it will get recommended because of the using of this SVD library, and root mean square error is reduced. One interesting component of this technique is that it wouldn't fit on the contents of the film, which the content-based recommendation was doing.
So the last and the final module which we have created, which is the final module, which is taken into consideration the best points of content-based filtering and the collaborative filtering. It is hybrid recommender. This techniques blends together the procedures we have in collaborative and content-based techniques. In this technique, we will get different recommendations for different users, although the movie is same. Hence, our recommendations are more personalized and tailor-made towards a particular user. Like now, if you will see in the first simple recommender, simply recommendation for top movies is there. We can do recommendations for top drama movie or comedy movie, and top movies with the top number of popularity and top number of votes will get recommended just on the basis of votes and popularity. In movie description based recommender, just on the basis of content of the movie, the cast of the movie, the crew of the movie will get recommended in description based recommender. So the Dark Knight Rises, the person who has watched Dark Knight Rises will get recommended first thing the Dark Knight Rises, the second part of that movie, since the actor and the director is same. Similarly, in metadata based, it is also a submodule of content based recommender, and it is also dependent on the content of the movie. Collaborative based recommender is used to give uncommon suggestions based on that vector library, surprising vector library, and it reduces the error and because of RMSE, and basically it helps in prediction of that movies which have very low amount of popularity, and it increases their chance also to get recommended. The final the final module which we have built is hybrid based recommender. So the example which we are showing is the user one, which is watching a movie Aviator, and similarly there is a user two which is watching the same movie Aviator. But as we can see, the user one gets recommended different movies after watching the same movie as the user two. He is also getting different movies recommendation. So this is basically tailor made towards personal preferences. It is based on different types of attributes, but just not based on any particular attribute. So it is tailor made, more personalized, more custom based, and this is the final module, hybrid based recommender. So results of this is the paper presents recommendation systems for movie using different approaches in Python programming. It takes the data set as input consisting of different movies and provides recommendation based on different approaches. And most of the shortcomings in one approach is being taken care by another approach. And a good recommendation system provides positive and usefulness recommendations. Also provide recommendation different from what an existing algorithm already provides. So the final is the hybrid recommendation system. And for references, we have taken references from different papers. Yeah, that's it. Thank you.
Thank you, sir. Uh, Yes, sir. So basically, in regular times, the content-based and collaborative filtering is more used. So we have made a new technique, which is hybrid recommendation, which is more or less combining the positive points of content-based and collaborative filtering. Yes, sir. So the attributes which you have taken into consideration are them. There are various attributes which we have taken into consideration. As we have taken the data set, it has more than 42,000 amount of data, and different attributes like genre, actor and director, and genre of the movie, the total number of votes he has received, the movie has received, and duration of the movie is also there. So they are different, and budget of the movie is also there. So there are different number of attributes. Based on these attributes, we have finally decided to make hybrid recommendation. In the content based, it is only based on actor and director of the movie and the crew of the movie. In collaborative, it is only based on the likeliness by a user like me to recommend. But in hybrid, it is more tailor made and custom based for different users for different likings. Like two users will get different recommendations based on their watching history and their liking of the movie, although they are watching the same movie right now. So this is
Yes, sir. So basically, sir, there are many different OTT platforms, and it is definitely okay. But what we can do is we can basically make a website and just a catalog of movies, not the original link or anything, just a catalog of movies. So like there are many like in today's era, there is recommendation is the important thing. So basically, he can just click on a particular movie, and then he can get the recommendations for different amount of movies if he likes that, like a person who has watched some movie and then he wants to watch that a different like that movie next movie with a similar taste. So he can just click on that, and he can just fill out his likings of 2 or 3 or 4 movies, and then he can get various different recommendations for different movies. So in this way it can be useful. So we have taken 5 data sets, and all of which are taken from Kaggle, and it has more than 42,000 amount of data. Yes, sir. We take database from IMDb. So people basically give their ratings on IMDb, and we are taking data from IMDb. So sir, it is updated.
Yes, sir. Yes,
Thank you,
sir.
sir.
Yes, sir. Yes, sir. Sorry, sir. Sorry for the disruption before. We have to come across because as a researcher, there are a lot of difficulties and we have to go face. Yes, sir. Yes, sir. So, as sir told, we have to think locally and act globally. So, my research topic is like prediction of epilepsy. So, what is epilepsy in the sense we in normally locally we say it is to be fits. Okay, it is not alone stopped with that fits actually. So beyond that, people are dying and it is endless disease because once it starts affected in our brain, till the lifetime end, you'll have that disease. Though drugs are available, it will have a lot of side effects too, and there is no surety in surgery also. So we have to think beyond as a researcher. So here we have thought about the prediction of that disease. So it is not a detection. So after it is occurring, it is not a detection. Before it comes, we have to predict it. So that's a forecasting. So as a part of that, we have thought, so what things to take, that is, we have considered EEG, that is electroencephalogram signals, which are going to show all your brain signals, what's happening in that. So these EEGs have been normally less, that is the amplitude is very less. So even it is when it is contaminated with artifacts in the sense normally people say it to be noise, but as a biology, Medically, you should tell that to be artifacts from our body itself, the noises from our bodies, the interruptions. So when it gets contaminated with the EEG, what things happen and how it is affecting our prediction of epilepsy. So we'll see that. So I am Bhanupriya Prathaban, a research scholar from SRM Institute of Science and Technology under the supervision of Ramachandran Balasubramanian sir. So here my topic is computation analysis of W-Mobica and search strategies in automatic electroencephalographic source separation for seizure prediction application. Here W-Mobica in the sense wavelet-based modified biconjugate gradient independent component analysis. The name is lengthier, but it is a normal ICA technique and we have altered few things. And SCR in the sense it is sparsity-based EEG reconstruction. So sparsity, as we know, literally it is less complex. So since EEG is more complex, we have to reduce the complexity too. Right? So when we go into the slides, now these are the outlines of us. That is introduction, literature survey, and we'll see what are the proposed work and the findings. Finally, the conclusion. So introduction, as I told, our aim is the prediction of epilepsy. So for the prediction of epilepsy, the biomarker we have chosen is EEG. So in that EEG, what is the real biomarker in the sense, the states of the EEG. So what is seizure and what are the states affecting that? So before that, EEG itself has been corrected from the artifacts of our body or from our body. Suppose when we tap the EEG from our body, like the closing of eyes, like moving our heads or biting our tongue or teeth, these are being contaminated with the EEG and it may confuse the neurologist to look like the seizure waves, that is the problematic waves. So the neurologist may get confused whether that is real abnormal EEG signals or a normal one. So the first step is to remove these artifacts and then to proceed with the detection as well as then the prediction. So classification, prediction, the later, whereas the preliminary part is a artifact removal. So as I told, this EEG is very less. That is the amplitude, it varies only from few microvolts to 100 microvolts, as well as the frequency is 0.01 to 100 hertz only. And this amplitude actually switches above this range when the artifacts have been corrupted in it or contaminated in it. So these artifacts actually it is coming from our body only. Fine. So our preliminary step is to remove these artifacts and then go for the subsequent analysis in any medical or practical applications. So now we'll see the motivation. As I told, since this is a preliminary step for any other medical application, so it has to be taken because it enormously alters the original signal as well as it influences the outcome of the BC application. So when we see other BC applications, the normal BC application, like what is our state, or seeing our brain waves, alpha, beta. So what is our state now? Those things, any normal, even normal brain applications, these EEGs, if it is altered with the contamination, automatically the signals are corrupted. So the BC applications results are being corrupted. So we have to remove this, as well as it reduces accuracy and sensitivity of the final application. And when we come in, these are like BC applications, other things are normal for engineering, whereas when it comes to medical, so the diagnosis and analysis of the other diseases are basically it is neurological diseases or dysfunctions that it will affect enormously. So our main aim is to remove these artifacts from the EEG. So when I tell artifacts, okay, what is it? I mean, I told it comes from a body. So how far it can come? That is from EEG. It can come due to the eye rotation, eye movement, eye blink, those things. Eye are nothing but ocular, that is electrooculogram. Then the muscle, that is biting and chewing up your when you chew something, or when you're going to teeth grind, talking something, when the EEG waves are tapped, when you do these things, the muscular artifacts will be corrupted. In the cardiac, actually, even the EEG waves have been corrupted due to ECG waves too. And mostly people like the corruption may happen due to electrode replacement. So when we say we are tapping the EEG, we all know it has been tapped using 1020 electrode system. So when we move this, actually when we alter this electrodes not in the position, or when it is not placed, or due to the disruptions, I mean, if it is placed near the heart, those things, the instrumentation artifacts will be corrupted. So below we have a diagram, image just that is when we tap EEG, how it has been contaminated with other artifacts and why we need to remove and how we need to remove. Finally, when we take these artifacts away, it's artifact free EEG. And as we see literature, since it's like artifact, noise removal, we have lot. That is when we see it is from ranging from normal ICA until now deep learning applications are available. But deep learning, you can also go for deep learning application. But when you think alone artifact removal is alone your aim, then you can go for those things and increase your complexity. Whereas our aim is not being stopped with this. We want to take this artifact images, EEGs, and we want to analyze it for the later stages. So we should also think about the complexity. That is, you need to reduce the complexity. There are a lot of techniques, whereas we need to think the memory less, the less memory used, as well as less complex, but better accuracy. And the contributions, as I told, the two techniques have been contributed for this artifact removal, that is WMOBICA as well as search strategy. So WMOBICA is actually, it is based on ICA technique or conventional technique, whereas SIR is nothing but a sparsity-based. Since I told we need to reduce the complexity, we have gone for sparsity, that is less complex, but a better technique. And both are being these both are being compared with their own state of art, and even these both are compared with their ones, and we have been finalized, which is better. So for comparing all these things, we need data. So we've got CHB, MIT, and SRM. Since from SRM Medical College, we have a medical college, and we have got easy data sets from there. And I want to mention that we have got ethical permission as well as funding for this project. So we have got two data sets. And when we look the first one, that is WMOBICA, since it is, we all know that is a ICA, that is basic BSS algorithm. In the variation of the ICA, one of the variation of the ICA is ORICA. Generally in ORICA, RLS is being used, whereas we are replacing this with the BCG, that is biconjugate gradient. Why do you want to replace these things? Why do you want to replace the mathematical equation in the sense only for one thing, that is computational complexity, that is to reduce your complexity? Then this is all not alone finalized, because you need to remove the artifacts. How to know which are the artifacts? That is, your peaks have been detected and it has been removed. So this one is your WMOBICA, and it has been compared with its respective state of art, that is WICA and IWICA. These are the recent state of arts, and how it is being compared we'll see later. And this is WMOBICA. So initially these BSS techniques equations have been given, and as we know, there is a W weight matrix and unmixing weight matrix, and you'll have the weight updation. And with this weight updation only, you'll go to later stages. Whereas in this only, people are using ORICA. In ORICA, RLS has been used. Whereas in RLS, your RLS as well as the exponential sliding window are being used. Here, since it is more complex, we have been replaced that with biconjugate gradient and as well as an adaptive window. See, exponential sliding window, instead of that, adaptive window is best used, because you need to know you need to remove whatever it is, that only the peaks have been detected, only that is removed. You're not concerned about everything. So these are the equations continued, and beta n is the final equation, and because of with this you've been replaced with the RLS. And later, see, after your ORICA is concerned, the RLS and your things are okay, your ICA process is okay, then you have to do what? You have to find the sample entropies and find the components, and from this the peaks are detected. How to detect your peak? What are the peaks? So you need to specify your threshold. So threshold here is fixed like, from the literature it is fixed like when it is twice time greater, as well as when your time is twice, that is twice 0.4 seconds, then those peaks are only marked. And since it is W, that is, we have used wavelet, so your DW2 is used, and to mark your to get your detail as well as approximate coefficient. Only the approximate coefficient here have been rejected completely, whereas the other one is kept. So in this, finally we have achieved less complexity, as well as only the artifact component is being removed. Intact, in fact, your EEG source component is intact and it is better. Fine. So the other one is your sparsity-based EEG reconstruction. As the name implies, sparsity, so it is less complex. So we want it because since EEG, as well as the data set here used is 23 channel, and just imagine 23 channel, and it's alone. It alone carries how much big matrix, and you're not even going to stop with this. You're going to analyze later. So you need to remove the complexity reduce the complexity as well as remove the artifacts. So here we are using sparsity-based EEG reconstruction. Basically, what is sparsity-based EEG reconstruction is, you have 3 stages, that is sparse coding stage, and with this sparse coding stage, that is your all raw EEG signals are being converted to sparse coefficients, and these sparse coefficients have been given to a dictionary, or people call that code book, and with this dictionary you need to update it. For updation, here we are using a PC algorithm instead of KSVD. Since it is SPD, that is you're going to find the, again, we are replacing PCA. So, and finally the artifacts have been detected. So the below image shows the SER technique, that is sparse coding stage as well as a codebook updation, finally estimation of artifacts. First, the sparse coding stage. In this, your sparsity-based matrix is present, and it is given to a codebook updation stage. That is, it has been updated, your dictionary is updated, your artifacts have been estimated, and it is subtracted from the raw EEG. And as I told, EEG, so a snap of that. And the first one, A, is your CSP MIT and SRM dataset. And here, the signals we have took, it is actually recordings are long term because you need to analyze it, as well as it is multi-channel, that's why it is complex, as well as it is non-invasive because it shouldn't affect the patient. And we have gone that scale. And each recording is taken for about 2 hours, since you need a lot of analysis later. And totally we have taken, only for this artifact model, we have taken 52 EEG recordings from 39 subjects from both SCHP MIT as well as SRM dataset. And these are the results. That is, as I told, we are going to compare WMBICA as well as search strategy with their own state of art, as well as they both are being compared. So the metrics taken here is MAE, RMSE, root mean square error, and your correlation, how much correlation coefficient, and the important thing is that is, people tell that to be SNR. Here is, since N is your artifact, it is SAR and mutual information. So from this table, we could finalize that your SAR is better than MOBICA, whereas your state of arts are in back with these 4 techniques. And the below image is nothing but you're going to we have compared WMOBICA as well as SCR, and it is very widely seen that SCR is better performing because it removed artifact more than that, because your blue solid lines are artifacts, whereas your red is artifact free EEG data. And actually the before one, what we saw, that was actually one channel, but here it is actually multi-channel. We want to show the multi-channel data, so multi-channel analysis have been done and the table has been used. And here the same. So when we put into the single image, so first one is artifact EEG, the next one is artifact removed using WMOBICA, whereas see, we could see the difference when it comes to WMOBICA as well as SIR is better performing, and it removed artifact more than that, as well as it is less complex. Okay, conclusion. So as from the images and tabulations, we could finalize that SIR is better performing than MOBICA. We have proposed but MOBICA is that is in terms of SAR or MIRCC, it is better performing, whereas SIR actually it is consuming 22.47 seconds. Since it is both, though it is less complex, it has a lot of stages, so it is it consumes more seconds than the other. So in order to reduce this time complexity, that is, you can go for the parallel processing for the later stages. These are my references. Thank you. And not long with this, we need to continue this with the prediction. My work has been prediction is over, and later we have already proposed for prediction and got 2 papers. And now the hardware has been over. And as sir told, the people are in the next presentation, we'll show the hardware also. Thank you, sir. Any queries? Thank you, sir. Thank you, sir. Thanks, sir. Sure, sir. The prediction we have considered about 300 data sets, sir. Whereas only for the artifact removal, as concerned with this presentation, I've gone to 52 recordings. 52 recordings alone, and the same has been, we have found which is better, and the same, and the SCR is replaced for the prediction stages, and we have got a paper on that telling like SCR is better performing, and in that we have used 300 recordings, sir. But in real time we have gone to transfer learning because 300 is not enough. Since this is accuracy should be more, so we have gone for transfer learning. As we know, it is pre-training of the model, and the hardware studies and all. Yes, sir. Yes, sir. Actually, since we are talking about the prediction of epilepsy, as we think it is just fits, but it is not so, sir. Once the brain has been affected with this, the lifelong we have to face and even drugs are available. Around 15 types of drugs are available, but a lot of side effects. And if you want to do surgery, the entire brain has to be in problem. So people thought about that, and they have gone to predictions, sir. In EEG itself, there are a lot of stages, and I want to capture the stage just before the problematic stage, and that's why it is called as forecasting, sir. And since that is actually captured, we can alarm the patients that that is our results. Actually, the other paper of one of the other paper, prediction paper, actually we have proved like I can predict the seizures 1 hour before, sir. We have got a paper in that 1 hour before we are able to predict the seizures, sir. And the preliminary part has been this artifact removal, sir. This is used in that, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Like you can that fits. People actually tell that to be fits, but it's not one fits actually. And you can want that because emergency services can be given, as well as medical persons can be contacted if it is 1 hour before. And since it in the frequency of occurrence is more for the person affected with seizures, that is if I am affected, like I cannot say one day only once it can come. The frequency is more. So at least we can reduce the frequency and save the person life. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you, sir. Thank you so much, sir. Any other questions? Thank you, sir. Thank you, sir. Thank you, sir.
Yes, sir. Yeah, Yuvaneshwari, sir. Yuvaneshwari. Yeah, yeah. Okay, sir. Yeah, okay. Yeah. So, good afternoon, one and all present in this session. Myself, M. Yuneshwari, full-time research scholar in SRM Institute of Science and Technology, Chennai. And my supervisor is Dr. M. Bhaskar, sir, Assistant Professor, Department of CSE, SRM Institute. And today my paper is on the title, A Survey on Segmentation and Classification Techniques to Detect the Brain Tumor Disease Using Machine Learning. followed by this is my abstract. So the irregular growth of the tissues, I mean the abnormal cells grow in the brain, which leads to the brain tumor, and we coined that function as said to be the brain tumor. So the accurate identification of the brain tumor is an essential diagnostic feature where the article benefits and disadvantages of recently arrived existing methods of the brain tumor diagnosis is addressed. A generalized flow map that is widely appropriate for the diagnosis of brain tumor is also suggested in this paper. Whereas various data sets are commonly available for access of the brain tumor algorithms are also listed. And we go for the performance metrics like accuracy, sensitivity, specificity, and time consumption in the comparative study. Followed by this is my introduction. So generally the brain tumors composes of unusual material that arise in the excessive cell growth, and this tumor had no functional significance within the brain. So the tumors are not just to increase the area of stress in the brain, where it leads to the swelling and triggers irregular neurological problems to the concerned patient. Whereas currently there is a huge demand for the effective, reliable, automatic approaches to the tumor detection. Whereas many type of images like PET, CT, MRI, and these are some of the images where the brain tumor can be easily detected. And the researchers' interest has recently grown in the use of deep learning methods to detect the brain tumors, where its efficiency and reliability can be increased. And there are different ways to detect the brain tumors, such as thresholding, where also global and local can be used. And in case of region, we go for edge, region growing, and watershed method. In case of shape, we go for atlas, level set, and deformable. And in this review, it provides a systematic overview of conventional machine learning approach and the development of deep learning models for detection of brain tumors. And these images show where the abnormal cells grow in the brain, and it is said to be a hemorrhage. Hemorrhage is in the image in the sense there is a brain tumor. And this is the methodology. In the existing method, there is the existing system consists only the single image of the patient, where the doctors come to the conclusion. Sir? No, sir, my PPT, can't you view my PPT, sir? So, sir, no, my screen isn't sharing only, sir. Sir, can't you view my screen? Sorry. Sir, any issues? Okay, fine. Thank you, sir. So in my existing method, it contains where the single image of the patient is known, and based on that single image, the doctors come to the conclusion that the brain disorder disease is there or not. And in fundamental multimodal image fusion methodologies, the source image is just overlaid by the different color channels, where each image has some color image fusion and pixel size. Everything it depends on the image, where the overlay approach is used to expand the amount of information over the single image, and it does not affect the image contrast or distinguish that image from the original image features. And also in existing model, the model faced a lot of problems related to decision accuracy, related to the brain problem, and these methods are used to found less useful for the higher applications in detecting the brain tumor disease. Moreover, the absence of image fusion has caused lots of accuracy problems, where the model is unable to predict the disease and to find the full accuracy. And in this proposed method, the medical image of the brain combines different modality of medical images to produce high quality images with spatial and spectral information, so that the doctors can easily predict or the time consumption can be reduced in order to give the proper diagnosis for the patient. And also it will perform analysis in the medical diagnosis application. We propose Nciem segmentation to segment the brain image. And generally the convolution neural networks, so brain image, and the CNN classifier helps to identify whether this is present or not. And this is a related work where the MRI image-based tumor detection using segmentation or classification as much more effective than the recent trends, where the huge number of works had exploited the strength of image segmentation techniques and aids for the careful diagnosis of the brain tumor. Like as I said before, brain tumor detection depends on various factors like income boundaries, because each and each entry is pixel size and can reduce image. It is important to future in tumor. This is my literature survey. These are the few papers we have done from the survey.